Hello Algebra 2. This video lesson is about Chapter 5.2, which is all about factoring of quadratic equations. And as the title says, we're going to end up learning how to solve quadratics using factoring, but first we've got to understand how to factor itself. This lesson is a review, so I may go through this faster than you did when you first learned this back in Algebra 1, and if it goes too fast for you, don't hesitate to come in and talk to me about it outside of class. I want to make sure that I alert you to this first paragraph here, which talks about something that's very important. We're actually going in the backwards order of what we were doing when we were using the FOIL method. In the FOIL method, I was taking this binomial and multiplying it times that binomial, and I was getting this trinomial, this three-term expression over here. Now, again, binomial and trinomial are vocabulary words that you're going to have to get used to because I'm going to use them a lot. Factoring is the opposite. I'm going to work from this trinomial, this three-term expression, and come out with two binomials. And let's see how you do that. To factor x squared plus bx plus c, kind of a generic or parent formula here, and end up with two binomials. They picked m and n as the numbers that are going to fill in for the constants that you would have if you had a real example. The way to get from this trinomial to that set of binomials, as they say here, you need to find the numbers m and n that add up to make this blue term. So in other words, you've got to find two numbers that add up to make b, but also multiply m times n to make c. So c is the same as the two numbers when they're multiplied. B is the same as the two numbers when they're added together. Let's look at a real example, and this is going to make a lot more sense. I do have to alert you to one fact, though. Everything that I'm talking about only applies in the case where your front or lead term is x squared. There can't be any coefficient on it. So if you think of this as ax squared plus bx plus c, then a has to be 1. As long as a is 1, everything that I'm going to talk about in this video lesson works. Alright, so here's an example where a is 1. I've just got simply x squared minus 12x minus 28. So as I said in the generic version, I'm trying to find a case where m times n equals negative 28, or in other words, two numbers that multiply to make negative 28, but also those same two numbers add to make negative 12. They add to make the middle coefficient, the b. Okay, so let's think of all of the factors of negative 28 that would multiply to make that. Well, here's a list here of all of them. Negative 1 times 28 does, but so does 1 times negative 28. And everything across here all the way down to finally 4 times negative 7 also would multiply to make negative 28. Now I look at all of these pairs, what are there, 6 pairs here, and I try to find one pair that's going to add up to make negative 12. And there's only one of them that does, that pair right there. 2 and negative 14 will multiply to make negative 28, and 2 and negative 14 will add to make negative 12. Great. So as this says, that means that x squared minus 12x minus 28 is the same as making use of this pair here, x plus 2 times x minus 14. Let me make sure that I was clear about this. If you tried x plus 4 and x minus 7, you're not going to get this trinomial over here. The only way to get this trinomial from two binomials is to use these two terms, the ones that fit the pattern that we just talked about, x plus 2 times x minus 14. All right, here's a batch of 6 different trinomials. And as I've circled here, it's possible that they can't be factored. And if so, I should say so. Well, I'm going to do 2 of them. I'm going to do number 2 and number 5. I'm actually going to do number 5 first. I've got to find the factors of 28. Well, what numbers multiply to make 28? Well, always, for any number I want to pick, 1 is going to be one of its factors, and negative 1 will be as well. If it's 1, then it's 1 times 28. If it's negative 1, then it's times negative 28, right? All right. There are other factors besides 1. Does 2 go into 28? Sure it does. And it would pair up with 14. as negative 2 would pair up with negative 14. Does 3 go into 28? No, it doesn't. How about 4? It does. 4 times 7. Okay. How about 5? Nope, it doesn't go in to 28. How about 6? It doesn't go into 28 evenly either. That's it. The door is closed. The reason I present factoring this way in what I call a rainbow pattern is because it's easy for me to tell when I'm done. I don't keep generating different possibilities. I work from one, working toward its pair, which is going to be 28, but as I do that, notice it pinches in from the left, it also pinches in from the right, and ultimately I'm going to end up with an area in here where I can't put anything more. And I know I've got all of the factors now of 28. All right, so now my job is just to find a pair. Remember, 1 paired with 28, just as negative 4 pairs with negative 7. I've got to find a pair of those that adds to make negative 11. And there is one of those 6 pairs that does. Negative 4 and negative 7 do. Add them up, you'll see they make negative 11. That means the factors of this trinomial are x minus 4 times x minus 7. And that's my answer. Second one that I wanted to do, x squared plus 6x minus 2, I've got to find the factors of negative 2. Well, as I say, 1 is always a factor. It's 1 times negative 2. And its negative version will also be a factor. But that's it. Those are my only factors of negative 2. Do any of these pairs, I should say this pair with this and this paired with that, do either of those pairs add up to make 6? No. There are no pairs that multiply to make negative 2 and add to make 6. That means it can't be factored. Okay, I've done those two. Your turn. Go ahead and do all 4 of those. Hit the pause button. When you come back, I'm going to show you the answers. Okay, I'm going to assume that you did that. There are those factors of each of the 4 problems I asked you to do. Hit the pause button if you need to and study these answers. But make sure that you can understand how all of these work properly. Just picking an example here, picking number 6. If I multiply negative 4 times negative 6, I get positive 24. If I add negative 4 and negative 6, I do get negative 10. So those are the correct factors. This is the correct pair of binomials that matches this trinomial. Now, as I said, we got to get to solving quadratic equations. To solve them, you're only going to be asked to solve if your expression, your trinomial, is set equal to something. If it's not, then you would have been asked to factor it. But here I can go ahead and solve and figure out what x is. First of all, they write the original equation, but I can't tell what x is in this equation because I've got 2 different variations on x. I've got x squared and I've got x. The only way I can do this is if I get both x's down to the same level, if you want to call it that, down to the same degree, the same exponent. And I do that by factoring this. That's why we teach you, or one of the main reasons why we teach you to factor trinomials, so you can get x down to a point where you can solve. Okay, so the factors of negative 18 are these. 6 and negative 3 multiply to make negative 18 and add to make positive 3. So I've got these 2 binomials now are equal to 0. Well, here's the key point. The only way these 2 concepts, the left binomial and the right, can be multiplied to make 0 is if one of them is 0. That means either x plus 6 has to equal 0 or x minus 3 has to equal 0. If x plus 6 is 0, then x is negative 6. If x minus 3 is 0, then x is 3. So my answer is that x is either negative 6 or 3. Or I could say x is negative 6 and 3 if I want to. You can always plug these back in to this equation and make sure you'll find that negative 6 times negative 6 is 36. Negative 6 times 3 is negative 18. So 36 minus 18 minus another 18. Sure enough, that is 0. 3 will also work if you plug it in. Okay, so now let's just look at this and make sure that the expressions that you factored before make sense when you try to solve. If I had changed the instructions that said solve these 4 equations, then I would have had to give you them equal to something. I'm going to set them equal to 0. That's the easy place to start. And we'll talk later in the next coming weeks about what happens when it's not equal to 0, but for now let's do the easy situation. Well, remember, we figured out that these were the factors, so those factors are now equal to 0 in every case. Hit the pause button. When you come back, I'm going to show you what x is for each of those 4, 1, 3, 4, and 6. Okay, I'm going to assume that you did that and you've solved for x. There are the answers. For number 1, x is either -7 or 3. Similarly down here for 6, x is either +4 or +6. And that's it. That's the lesson. If you have any questions, don't hesitate to come into class. I look forward to seeing you.